In just the last century, it's estimated that global temperatures have risen 1.2 to 1.4 degrees Fahrenheit. This change in climate has had impacts across the planet as we've seen more extreme weather conditions, sea levels rising, and more frequent megafires. In the face of this changing climate, it's important that we try to understand the potential impacts it may have on our ecosystems, as climate research has the potential to influence resiliency on our landscapes through both policy and land management. One such lab at University of California, Berkeley is already taking those steps to understand the impacts climate may have within our ecosystems and the adaptability of our landscapes.
So my lab studies plant ecology, evolutionary biology, and especially how plants are impacted by climate change and just how plants are distributed in relation to climate, and we focus on California. So starting from that framework, about 8 years ago, we set up long-term forest plots in Sonoma County at a location called Pepperwood Preserve. So it's a very rugged landscape, like a lot of the Central Coast. So every north-facing slope is a little cooler, and the south-facing slopes are warmer. We have little microsites that give us a picture of cooler sites and warmer sites. And then we use that then to think about sort of a model for what the future could look like, and how does that help us think about what the forest might look like under a warming climate. When we think about a changing climate, we do need to understand first what's happening if we're going to think about how we're going to respond. We know over geologic timescales, yes, climate changes, it's driven by ice ages, it's driven by these different factors, and plants and animals respond. They evolve, they move around the landscape. But with a very few exceptions, those changes happen slowly, at least over thousands of years, if not tens of thousands or more. What we really don't know is what happens when climate changes as fast as it is this century. We have expectations about how nature responds to a changing climate, but do those expectations really play out when it's as fast as it is now? If we think about now, like, how is climate change impacting the ecosystems now? Well, we have a lot of good evidence that the intensity and the size and the frequency of wildfire is increasing because of hotter temperatures. And that's data that's been analyzed across the entire western United States. We would not expect the intensity of the fire we're having now under the temperatures we had, say, 30 years ago. So yes, the impacts of fire on these landscapes are in part the impact of climate change, because this increase in intensity definitely reflects a changing climate.
So as part of the Ackerley Labs research, a plot network was established here in Pepperwood in 2013. And the initial idea behind that research was to look at forest structure and composition and how that changes over time in the face of climate change. In October of 2017, the Tubbs Fire came through the preserve. In the first night of that fire, when it spread into the Santa Rosa city limits, there was really high intensity burn that happened on Grouse Hill, and some of our plots were burned really severely that first night. Over the next few days, the fire moved through the rest of the preserve, and there were some plots that burned at a moderate intensity, and then some plots that burned at a low intensity, and some plots that didn't burn at all. Then, in 2019, the Kincaid Fire came through in the completely opposite direction. It came from the north, and the plots that didn't burn in Tubbs burned at the highest intensity. The plots that burned moderately in Tubbs burned moderately again during the Kincaid Fire, and the plots that burned at the highest severity in the Tubbs Fire didn't burn at all in the Kincaid Fire. So while initially our goals were to look at forest structure changing over time, now we had the unique opportunity to look at how the forests were responding after a severe fire, and then how they responded after a second fire at such a short interval. It's really important to be consistent in data collection, but the nature of this research demands that we collect the most relevant data for the situation that has presented itself. And as climate change continues, I think that scientists will have to pivot often in order to collect the data that is the most relevant.
As the Ackerley Lab has seen, there are implications for the changes we're seeing in our climate. Through research, however, these changes can not only be anticipated, but managed for. As seen in the fieldwork at Pepperwood Preserve, adaptation to these impacts will be imperative moving forward and could lay the foundation in how we promote resiliency on our landscapes in the face of climate change.